Section 10.3 Geometric Sequences and Series. Objective number 1. Determine whether a sequence is geometric. Example 1. Determine whether the sequence 2, 6, 18, 54, 162 is geometric. If it is, state the first term and the common ratio. So, in order to find that this is the geometric sequence, we need to find the ratio. We need to take the pairs. So A1, A2, A3, A4, and A5. So let's say I pick A1 and A2, then I will divide. We remember that we always divide from the back, divide the one in the front. So 6 over 2. And then we take A2 and A3, then 18 over 6. Now we take A3 and A4, we will have 54 divide 18. 162 divide 54 for A4 and A5. And you notice that you get the same number, so that is 3. The other ways that we can see is that from 2 go to 6, from 6 go to 18, from 18 go to 54, we multiply by 3. And how do we find the number 3? We divide. So 3 is called the ratio, the common ratio. And the notation for the common ratio is or. The first term is A1 is 2. In example number 2 and number 3, they give you a sequence. If you want, you can plug in n equal to 1, 2, 3, 4, 5, and so on. Then you will have a list of a number. Then you can just do the same way as example 1. Or we just do this one. So let's say that the 3 to the negative n, the location is an. In this case, it's bn. Then the next location have to be 3 negative n plus 1. Then that is the b of n plus 1. Then you just go ahead and divide. So 3 negative of n plus 1 divided by 3 negative n. What do you want to get from here? If you simplify this expression and you got the answer is a number, it's telling us that this is the geometric because it's a ratio. The ratio is a number, just like example number 1 we did. If you divide and you do not get a ratio is a number, it is like a letter, then you can conclude that this is not geometric. Now we simplify this. So this is the same as 3 to the negative n plus 1 minus of negative n. You recall that we have a to the n divided by a to the m. We have the same base, we just subtract the exponent. So let's open the parentheses. And the 2 minus n is become plus n. So we got the answer is 3 to the negative 1, and that gives us 1/3. So this is a geometric, and the ratio is 1/3. Example number 3 is similarly like example number 2. This is your an is equal to n squared plus 1. What if we move on to the next number, the next term? Then you will plug in n plus 1 into the n location. And then to find the ratio, we will divide. We take the one in the back, divide the one in the front. And what do we expect the answer will be? The answer that we want to see is a number. Now we simplify this. I'm going to separate. So let me expand this. And then we get n squared plus 2n plus 2 divided by n squared plus 1. We want to factor this, and then we can simplify this. That's what we do to simplify a rational expression. But look like on the top we cannot simplify anymore, and in the bottom we cannot do anything more, then we cannot do factor. So the expression that we simplify doesn't give us a number, it gives us an expression that containing a letter n inside. So we can conclude that the geometry that they give to us is not right. That is, the sequence is not geometry. So an is not geometric.